Alright, good afternoon, ladies and gentlemen. So today we're looking at lesson 2.7, solving quadratic inequalities. The two objectives for today are to solve quadratic inequalities using tables and graphs, and then to use algebra as well. There's a warm-up here. Find the zeros of the equation below using the quadratic formula. So take a moment to pause the video, then go through the quadratic formula on this example problem. So you should have gone through and solved this using the quadratic formula. To review with you what that looks like, remember we want to get everything on one side, so we have to subtract the 18 over. So it gives us 2x squared plus 12x minus 18 equals 0. Using the quadratic formula, we would get negative 12 plus or minus the square root of 12 squared minus 4 times a, which is 2, times c, which is negative 18, all divided by 2 times a, which is 2. Doing a little bit of simplifying here, we get x equals negative 12 plus or minus the square root of 288, all divided by 4. I wrote a little bit too big, so I gotta shrink this down a touch. There we go. All right, so now simplifying this, the square root of 288 goes into simplest radical form as, let's see here, that would be 12 root 2, and then that's divided by 4. And then we can actually simplify that a step further because the 12 here and the 12 there in front of the radical sign are both divisible by this 4. So if we divide them both by 4, we get negative 3 plus or minus 3 root 2. All right? And that's a warm-up problem with the quadratic formula. So today we're going to be talking about two types of quadratic inequalities. The first is going to be with two variables where you have y being less than or greater than or equal to a quadratic equation. The other one is going to be with just one variable where you have a number with an inequality sign and then your quadratic equation. So with the first one with two variables, we'll solve these graphically. We'll graph the quadratic expression that's on the right side, like we would any quadratic expression. Then we'll be doing some shading. So there's kind of three things to keep in mind when you're solving by graphing. First, you're going to graph the parabola as you would any quadratic equation. So finding the vertex and then finding two other points, one to the left and one to the right of the vertex. Then you'll use a solid line if your inequality sign has the or equal to symbol underneath it. If it doesn't, then you'll use a dashed line. The solid line to say that we could be satisfied on the parabola, a dashed line to say we'll get infinitely close to that parabola but not actually be on it. Then you'll do some shading, and you'll shade above if your inequality sign says greater than. So you'll shade to the region where the y values are larger, or you'll shade below for any y values that are smaller when you have the less than sign. So let's put this to practice. In example 1, we want to graph the inequality 2x squared minus 5x minus 2. One way to go through this process to graph it is to find some of these key features of y-intercepts, vertex, and zeros. So our y-intercept is our c value of negative 2. So that means on the y-axis, I'm going to have a point at negative 2 here. If we go through and calculate the vertex, you could do that by finding axis of symmetry and then plugging it into the function to find the xy coordinate of your vertex. You could do that graphically by typing it into the calculator to find the minimum, whatever works for you. But we would get the point 1.25, negative 5.13. So we're going to graph that point, which is going to be about here. From there, you could do your best to reflect the y-intercept over this line for the axis of symmetry, or you could go through and calculate and find the zeros. You could do that by using the quadratic formula, like we did in the beginning, but then you would want to round that to decimal so we could actually graph it. So the zeros here would be negative 0.35 and 2.85. So at about negative 0.35 and 2.85. So doing our best to graph this with the information that we have. This is not the best picture of the parabola, but it's okay. I have some of those key points, so that's fine. Oh, and actually, I graphed it with a solid line without putting much thought into it. So let's go over why I graphed this with a solid line. I graphed this with a solid line because my inequality in the beginning has the or equal to bar underneath it. So because of that, that is why I graphed this with a solid line. If it hadn't, then I would have graphed it with a dashed line. Now let's talk about shading. My inequality sign says y is greater than. So that means I want to shade in the part of this parabola where my y values are getting larger. And notice that happens when we are inside these parabola boundaries. Because technically, even though I didn't graph it all the way, this parabola would continue going on infinitely on those ends. And so the area that I'm going to be shading is everything inside because that's where my y values on the y-axis are getting larger.